All right, welcome to Mr. Richmond's specific heat intro math tutorial. I got an index card down here. I'm going to add a little extra to what's just on our sheet, but so we want to start by talking about our equation. Okay, our equation for specific heat is Q equals mc delta T. So before we do anything else, we need to talk about what everything here is. So first, Q. Q is energy. Okay, Mr. Richmond, why didn't we use E then? Well, just to think of it this way, think about Q as quantity. Because what this really is the quantity of energy transferred. Okay, and we're going to measure that in joules. M is mass. We're going to measure that in grams. Okay, so these next two things are where things get weird. So C is a thing called specific heat. That's what we're doing. We're working on specific heat. So this is specific heat. And the unit for this is going to be joules per gram degrees Celsius. Now, some of you are out there yelling at your computer screen right now. This could also, for us right now, be joules per gram Kelvin. But the lab that we're going to do using this is utilizing the Celsius scale. And in Celsius, the magnitude of a single degree is the same as the magnitude of a Kelvin. So if something increases from 0 to 1 degree Celsius, it goes up by 1 degree Celsius. That would be like going from 273 to 274 Kelvin. They're the exact same magnitude of change. So because our thermometer is going to use Celsius, we're going to put Celsius in here. And that brings us to this. What the heck is this? It's one thing. This is delta. Delta means change. And this is T, meaning temperature. So this is the change in temperature. We are going to measure that in our lab in degrees Celsius. Thus, the degrees Celsius over here on our specific heat. Okay? So, when we come to our worksheet, Q equals mc delta T. What does Q stand for? Well, Q stands for the quantity of energy transferred. And we are measuring that in joules. So now, based on our sheet here, we know that M is mass, and we should be measuring that in grams. C is specific heat, and that should be in joules per gram degrees Celsius. And delta T is change in temperature. That should be in degrees Celsius. All right, so now that we have all of that situated, we need to figure out what we're going to solve for. So right now, we know if we're going to solve for Q, we're going to use Q equals mc delta T. But what if I have to solve for M? Well, thinking about the rearranging equations that we've been working on, Q equals mc delta T. All right. Perfect. I want to get m alone. Get it to be m equals something. Well, I'm multiplying everything. So divide. Divide by c. Divide by c. If you've watched the other videos, you know this thing. It's coming back to that. It's the balance. I did something to this side, I got to do it to this side. Delta t is 1 unit. We treat that together. So divide by delta t. Divide by delta t. M is now equal to q over c delta t. Well, that process is the exact same process for this entire thing. If I come into this one, q equals m c delta t. If I want to do delta t, divide by m and c, divide by m and c. My equation, if I'm solving for delta t, q over mc. Well, what if I want to solve for c? Q equals mc delta t. Ooh, this one looks more complicated. The c's in the middle. What do? You do the same thing. Divide by m, divide by delta t. Well, I better divide by m, divide by delta t. C equals q over m delta t. Okay? That's it. That's the whole thing. Now, I'm going to work this, but I'm going to work it on an index card so that I'm not squeezing it in here. Okay? So let me slide this up. I want to show you the 5 things I'm looking for when you do a word problem like this. So when I'm reading through this, I know in this case that Q equals mc delta t is my base equation that I'm going to use. So I should be looking for 4 basic variables for my knowns and my unknowns. So I'm going to start reading through this. A substance has a specific heat of 3 joules per gram degree Celsius. Specific heat. Specific heat is C. So 3 joules per gram degree Celsius. Okay. If you have a mass of 1 gram, I want to raise the substance by 1 degree Celsius. Celsius, that's temperature. 1 degree Celsius. How much energy will you have to transfer? Well, we're in luck. I don't have to rearrange my equation. So step 1 is always knowns and unknowns. Step 2 is to rewrite the equation based on my unknown. Well, it's the base equation. If the unknown had been m, I would need to use that. That would be my equation. So there's part 2. Figure out the equation I'm using. Part 3 is just plug it in. As long as you can match things, you can do part 3. M, 1g, 1 gram, times C, 3 joules per gram degree Celsius, times 1 degree Celsius change in temperature. So now when I plug that in, 1 times 3 is 3, times 1 is 3. But it's a little awkward because there's no unit. That's not good, because step 3 was this. Step 4 was my answer. Step 5 is my unit. I need to figure out my unit here. Well, here's the thing. What that really, really looks like, if I kind of break it down, and why this is happening, is 1 gram times 3 joules over grams degree Celsius times 1 degree Celsius. So my degree Celsius is on the top here, but it's on the bottom here. They cancel. Grams is on top, on bottom. They cancel. So the only unit I have left is joules. That is step 5. That is the answer to question 1, part A, on this sheet. And that is the end of Specific Heat Intro Math tutorial. So I look forward to seeing you again soon, but that is it for today. So if you have any questions, let me know, and we will keep rolling with Specific Heat. The lab is the other part of this, so you'll see that in another video. Have a good day.